Well, and welcome back. So we've seen the formation rules, and what we're going to do is just look at some examples, and what I'll do is I'll tell you informally what they mean. So 0 on its own is a formula, and it says false. It's the formula which is never true. A on the formula, A on its own is a formula, and it just says A. Whatever the value of A is, it asserts the value of A. Most formulas, you can't tell whether they're true or false if you don't know the values of the variables that are in them. A implies B just says, well, there's different ways of saying it, if A, then B. This one here, and I don't blame you if you initially can't remember which is which. This is the conjunction one, and this is A and B. This one here is the disjunction one. This says A or B. And this one says not A. Now, just to help you out, I'll write some of these in conventional notation. This is A or B. And these are, the rest is conventional notation. But if you were forced to use them as binary, these as binary operators, you get the same mess. There's some things that don't work very well at all. So let me tell you a bit about how they work when there's more than one. So for example, that says A and B and C. Now, why don't you try your hand at it, see if you can guess. Now this, you really are guessing because I haven't told you exactly what's going on, but I think you've made a good guess. I can say you can have any number of formulas in here, so in particular you can have only one formula. For the others, what does this say? If A and B, if this says A and B and C, and this says A and B, what do you think this says?
A.
Just says A. So it's sort of redundant notation. Similarly, it says A or B or C. Now I should mention that this is the inclusive or, so it's really just, it's either or. It's either or A, it's, well, I guess a better way of putting it is and or. So so it's A and or B and or C, but I won't always write and or. From now on, or means inclusive or. So it means A or B or C, and I won't even ask, this also means A. And the two questions are, what is this and what is this? And I want you to say, yeah, Andre, then Donna. Yeah.
I think the conjoint one is true and the disjoint one is false, because the set of all things that are true in it, they're all technically true because
there's nothing to be false.
Because there's nothing to be false.
Yeah.
So, but the other one is that it's only true when at least one of the objects is true. There's nothing true in there,
yeah.
So it has to be false.
That's right. Is that what you're going to say, Donna? Yeah. You're right. So you go. We're done. So there aren't any formulas. So when I question whether they're all true, the answer has to be yes. And the reason that all the formulas in between these brackets are true is because you can't show me one that isn't true. This is no counterexample interpretation. So that is true. Now this one is not so controversial. Disjunction says that at least one of the formulas between the brackets is true. Well, clearly, since there aren't any formulas in the brackets, there can't be any that are true. So if I say there is a Russian exchange student who also plays basketball, that's clearly false because there aren't any Russian exchange students. But there shouldn't be a problem about that. What about implication? Because implication, there's two sides of the arrow. So you could have a varying number of formulas on the left and a varying number on the right, and it takes some getting used to see how that works. And how it works is a little bit surprising, although once you get into it, you realize it's very, very useful. So let's take a really simple example. So in natural language, what does this say? That's the easiest one to do. It says if A and B, then C. And that's almost a standard concept. It's very, in real life, or even in the sort of exercises, the logic word problems, it's pretty unusual that you just say if A is true, then B. If you notice some of the word problem, I'll give you some word problems. If the weapon was a knife and the murder occurred in the garden, then blah, blah, blah. That's a very common phrase. So all these have to be true to make this true. Let's look at this one here. Now I'm really going to test your understanding. Now, assuming we're using the mathematical conventions, not the everyday conventions that Aristotle used, what is this saying? Saying you're unequivocally stating C. Because what you're saying is if all the things on the left are true, then C is true. Are all the things on the left true? Yes, because there's no counterexample. Now let's try another one. So what this says, and I'm still cutting a few corners, is if all the F's are true, then at least one of the G's is true. So this makes sense no matter how many F's there are and no matter how many G's there are. But the only thing you have to bear in mind is we're using the modern logical conventions for when there are no F's, when there are in fact no F's. There's another way of writing this which avoids that whole issue. So at least one of the G's is true and or at least one of the F's is false. So that's another way of putting it. Maybe that helps. Then it's probably a little easier to see. What this says is that one of the F's is true. Well, that's not going to happen because there aren't any. But one of the F's is false. It's not going to happen because there aren't any. Or one of these is true, which is the same as C or D. C and or D. What does this say? What this is saying is that if all of these are true, then one of these are true. Well, there's no way that one of these can be true. So if this assertion is correct, then we can't have A true. A can't be true, otherwise we would have forced the truth of some member of the empty set, and that isn't going to happen. So what this says is not A. So what is this saying here? Yeah, it's not A or not B or not C, or another way of putting it is it's not the case that A and B and C, which is the NAND operator. So saying they can't all be true, so the remaining case is the completely empty implication. What it says is if all of these are true, then one of these is true. Well, in fact, all of them are true. So that part of the implication. However, none of these are true. So what you have is it's equivalent to a true thing implying a false thing, and that's false.